Today we are going to understand the concept of Laplace transformation. But before we go to an example to solve the Laplace transformation, we should first know that what is Laplace transformation and why do we need Laplace transformation. We need Laplace transformation to solve ODEs. Let's say you get a very complex ODE and you are not able to solve it. So there we use Laplace transformation. From here, we will take an example of ft equals to sine 2t to solve and explain to you what is Laplace transformation and how it is used in various conditions.
Before going to the question, we will learn a little about the Laplace transformation. Let's say we have a function ft. Its Laplace transformation would be L of ft, which would be equal to e to the power minus st ft integrated from 0 to infinity dt. Now in the question, we are given that ft is equal to sine 2t. So its solution would be the L of f of t would be equal to e to the power minus st, and here ft is given sine to t, so we will write sine to t dt integrated from 0 to infinity. Now we will solve this by integrating by parts. We will treat this as first and this as second. So on solving this, we first integrate the first part, e to the power minus st upon minus s dot sine to t minus integration from 0 to infinity e to the power minus st upon minus s, and then we will differentiate the second part, that would be 2 cos 2t dt. Now again, this part of the equation would be solved by integrating by parts, where we treat this as first and this as second. So on further solving, we will get e to the power minus s upon minus s dot sine to t minus e to the power minus st, and when we will integrate this first part, we get minus sign and minus s and minus s both in the denominator, that would give s square dot 2 cos 2t minus integration from 0 to infinity e to the power minus st upon s square, and then we will differentiate this part, that would get us 4 sine to t, and whenever we differentiate cos to differentiate cos t, then we get negatives of sine t, so here we will write plus. This would be integrated from 0 to infinity till dt. Now the limits for this equation would be 0 to infinity, and on opening the brackets we get e to the power minus st upon minus s dot sine 2t from 0 to infinity minus e to the power minus st upon s square dot 2 cos 2t minus integration of from 0 to infinity e to the power minus st upon s square dot 4 sine 2t dt. Now if we bring the 4 and s square outside of the integral, then we will get something like this, minus 4 by s square e to the power minus st sine 2t dt. Now do you remember something like this? The Laplace formula that we used in the function ft is similar to this, that is e to the power minus st sine to t dt integrate from 0 to infinity. So if we treat it as I, then we get I, then we can also write this as I. So we can write this as e to the power minus st upon minus s sine to t integrated from 0 to infinity minus e to the power minus st upon s square dot 2 cos 2t from 0 to infinity minus 4 by s square I. So if we go and put it here, we get I 1 plus 4 by s square. Now we start putting limits in this and this. We get e to the power minus infinity upon minus s sine infinity minus e to the power 0 sine 0 upon minus s minus e to the power minus infinity upon s square cos infinity, and plus e to the power 0 dot 2 cos 0 upon s square. As we know that if e is to the power minus infinity, it will tend to 0. So this term becomes 0. This term, because of sine 0, becomes 0. this term also, because of my e to the power minus infinity, becomes 0. So we are left with I. Taking LCM on this, we get s square plus 4 upon s square, and here we would get e to the power 0 is 1, cos 0 is 1, so we will get 2 by s square. Now by cancelling these terms, we get I equals to 2 by s square plus 4. That is the Laplace transformation of the function sine 2t. Now we will derive a general formula from this. The general formula would be that if we are given a function ft which is equal to sine omega t, then its Laplace transformation would be equal to omega by s square plus omega square.
I hope you got to understand the concept of Laplace transformation and will further be able to use it in more complex situations. Thank you.